Today my mom is going to tell you about radical equations. Solving radical equations. There are two new steps. Number 1, isolate the radical.
This contains the variable.
Number 2, undo the square root. Square both sides. Example number 1. This is going to be totally awesome, peeps.
Remember, you are still trying to isolate the variable. Since the variable is underneath the radical sign, you need to get rid of the 7 in that first example. So to get rid of the 7, you would subtract 7 on both sides because all of your rules of equality will still apply. So when you subtract 7 on both sides, the positive 7 cancels out, and you are still left with the square root of x. On the right side of your equation, you're left with 9. Well, we always want a variable by itself, so we don't want the square root of x, we want x. So we need to think of how we undo the square root. Well, to undo a square root, you square it. So if you square one side, you have to square the other. And the square root of x squared is just whatever is inside, so that's x. And 9 squared is 81. And of course, when we first started talking about how to solve equations, we talked about the importance of plugging it back in. So if you plug 81 back in, that would be the square root of 81 plus 7 is equal to 16. Now this is just simply order of operations. You would take the square root of 81, which is 9, plus 7, which is 16, and 9 plus 7 is 16, and that is in fact equivalent to 16 on the other side. Example number 2. Again, the whole goal of solving equations is to isolate our variable. And if you look, we have 2 t's and they're on both sides of our equation. So I know eventually I'm going to have to move some t's to get them isolated on one side, but I have some square roots. So I don't really want to deal with square roots. So the first thing I'm going to do is undo both of those square roots by squaring both sides. You can do anything to both sides of an equation as long as you do it to both sides and it remains equivalent. So if I square both sides, when I take the square root of 5t minus 11 squared, I get whatever's inside, which is 5t minus 11. On the other side, when I square that, I get t plus 5. And now I have a simple equation with variables on both sides. I am going to subtract t on both sides because I like to have a positive coefficient in front of my variable. So I get 4t minus 11 is equal to 5. Then I am going to add 11 on both sides, and I'm going to get 4t is equal to 16. Divide both sides by 4, so I get t is equal to 4. And of course, to make sure that I have it right, I'm going to plug in 4 into my original equation. So that would mean the square root of 5 times 4, which is 20, minus 11, is equal to the square root of 4 plus 5, which is 9. That's the square root of 9 is equal to the square root of 9, which I can already see that that's an equivalent statement. Or I could simplify it and say that 3 is equivalent to 3. So I know that my solution was correct. 2 more examples. 1, when you go through the process of solving equations, sometimes because we square something, it gives you the illusion, I guess if you want to call it that there's like a positive and a negative answer, but really when you plug it in, it doesn't work. And you'll see what I'm talking about after you do a few of these. So on this first one, under extraneous solutions, I need to get my n isolated by itself. So the first thing I need to do is undo this square root. So I'm going to square both sides. So I get n squared is equal to n plus 12. Well, I can't really get n by itself because I have n squared and I have just the single variable n. So I'm going to think about the magic I know that happens at 0. So I'm going to set this equal to 0 in standard form. So I'm going to move everything over and get n squared minus n minus 12 equals 0. All I did was use the inverse operation to move that over. Now I know that I want a product, so I can get this into the product of two binomials by factoring this. So since it's a quadratic equation, I am going to look for my two factors that multiply to negative 12 and add to be negative 1. So that would be minus 4 and plus 3, and that would be equal to 0. Well, then I can solve it. Well, n can be 4, and n can be negative 3. It looks like there are two solutions. But if I plug these back in, if I plug in 4, I get 4 is equal to the square root of 4 plus 12. And that's true because 4 is equal or equivalent to the square root of 16. So 4 works. When I plug in 3, I get, negative 3. Negative 3 is equal to the square root of negative 3 plus 12. Negative 3 is not equivalent to the square root of 9. And last but not least, you're going to have some equations without a solution. So we're going to try to isolate our variable by subtracting 8 on both sides. So you get the square root of 3y is equal to negative 6. Well, I can tell you right now you can stop because you cannot take the square root and get a negative number. That would mean that the number underneath has to be negative, which you do not get a real solution. But let's just continue through the process. And if you square both sides, if you square your square root of 3y and you square 6, you get 3y is equal to 36 divided by 3. So you get y is equal to 12. Well, if you plug your solution back in, check this out. That would mean the square root of 3 times 12, which is the square root of 36, plus 8 is equal to 2. Well, the square root of 36 is 6, plus 8 is not 2. So that is a radical equation with no solution.